A patient receives a dose of painkiller. The function p of t equals, in the numerator, 2t squared plus 10t, denominator t cubed plus 1, and it models the amount of painkiller in the bloodstream over time. T is hours. P is painkiller in milligrams. It's a calculator problem. We're going to need it with this ugliness. So part 1 is going to be find p of 2. Part 2 is going to be finding the average rate of change, and part 3, also known as C, is going to be the maximum amount of painkiller. So let's whip out a calculator, do each part at a time, see what we end up with. All right, so first things first, we have to plug in this formula. Whenever you're plugging in a formula, two things in this case, t's or x's, that's fine. But thing number 2, since we have a fraction, let's make sure we wrap the entire numerator in parentheses so that we have 2x squared plus 10x all in one parentheses. Then we can divide t cubed, so x, we'll do math 3 for cubes faster, plus 1. All right, hitting graph, there you have it. Now, what we're going to do is part number 1 is asking us to find p of 2 and explain your solution in context. Two ways that we could do this. The easiest way to find p of 2 is by hitting second table and going down to 2. That's our p of 2, which is 3.11111. So let's go back to our slides and write out 3.11111. All right, so we ended up with 3.111 going on forever. And what that means in context means after 2 hours, we had 3.111 milligrams of painkiller in our bloodstream. So 3.111 milligrams of painkiller in the bloodstream at 2 hours. And so we'll write it out that way because we don't have space to write everything else. B is asking us to find the average rate of change from t equals 1 to t equals 2. Let's write out B here because I, again, stole this stuff from the internet and I didn't give myself a whole lot of space. The average rate of change formula is f of B minus f of A over B minus A. So in this case, what we're going to do is we're going to find out what f of B is, which we already did. If it's 1 to 2, that would be like an A and that would be like a B. So we know what f of B is. We know what f of 2 is. Minus f of 1, we don't know what that is. All over 2 minus 1. So let's run to our calculator and figure that out. Part 2 of this is asking us to find the average rate of change between the intervals 1 and 2. So I'm going to go back to my table. Second graph goes back to my table. I'm going to use the values for p of 2, which I already found out to be 3.11111, and p of 1, which was 6. So I'm going to use 6 and 3.11111 in that order. So while I'm here, I might as well do it because the numbers are friendly enough. Parentheses 3.111 minus 6 all over 2 minus 1. So divided by 2 minus 1, I think I can handle the 2 minus 1 part, but I'm typing it out anyway because it takes time. And we get negative 2.889. So let's go back to our slides and figure out what that means in the real world. All right, so the calculator reminded us that that was 3.111 minus our new value, which was 6, all over 2 minus 1, which ended up being 1. Typing that out in our calculator was negative 2.889. Now, what that means is at this moment between hours 1 and 2, we lost 2.889, lost because it's negative, milligrams of painkiller. So that's the value that we get. And again, that means in the real world that we went from 6 to 3.111 milligrams of painkiller in our bloodstream. And so, that's the rate per the 1 hour that we had. Now, C is asking us to find the maximum amount of painkiller. And so we're going to use our calculator to use the maximum value and find out what we get. Our last thing we have to do is find the maximum amount of painkiller. So let's go back to our graph. And we have this picture where when time equals 0, and by the way, we don't care about negative time because that doesn't exist in the real world. It shoots up and then it comes back down. All right, so our max lives right around here somewhere. The way we can calculate our maximum is we go to second calc and use the maximum value 4. So obviously it comes up and it goes back down and it never, reappears. So I'll use 0 as a left bound. I'll use, I don't care, 6 as a right bound, enter. And so it's going to tell me my maximum is going to live between 0 and 6, which looks to be the case. So hitting enter one more time tells us that a maximum occurs at 8.51 hours. And that maximum is going to be 6.161, I think, was milligrams. So let's go back to our slides and write all that stuff out. So part C, the maximum value ended up being 6.161 milligrams, and that happened at 0.851 hours. So calculator problem, lots of fun. I hope you'd enjoyed it as much as I did.